So our goal for this video is we're going to use the flipud, fliplr, and rotate 90 degrees functions to derive matrix B from A and then matrix C from A. So first of all, let me define those three functions and what they are. So flipud function accepts a matrix name, and what it stands for is flip up and down. What it will do is it will flip a matrix upside down, basically. So if you have row 1, 2, 3, 4, 5, it will make a new matrix that's flipped. So the row 5 will be a new row 1, row 4 will be a new row 2, row 3 will remain the same in this case, and row 2 will be a new row 4, and row 1 will be a new row 5. So it will just flip it upside down. The fliplr function also accepts a matrix name and its parameters, and then what the fliplr function stands for is flip left to right. So we'll imagine there's an imaginary y-axis around here. What it will do is it will flip this entire matrix around that axis. So it will flip it. So this column 1, 2, 3, 4 would be the new matrix would have column 4 first, then column 3, then column 2, and then column 1. Now, the rot90 function also accepts a matrix name and its parameters, and what it stands for is rotate by 90 degrees. It will rotate a matrix, for instance, this matrix A, 90 degrees counterclockwise. So that goes from right to left, basically, or rather left to right. So it goes like that, counterclockwise. So here we have we're going to do an example problem, and that's how we're going to learn how to use these functions. So here we have matrix A of size 5 by 4, and our first goal is to get matrix B from matrix A. Now, one thing before we move on that you have to keep in mind is that if your new matrix, for instance, here B is of size 4 by 5, and matrix A is of size 5 by 4. Now, if you want to get matrix B from matrix A, using flipud and fliplr function, you have to make sure that matrix B is of the same size to use it. Since you want B and it's of size 4 by 5, and you want it from A, which is of size 5 by 4, you cannot use flipud and fliplr functions. In this case, you have to use the rotate 90 functions. So the way you should think about it is, if the dimensions flip, you have to use the rotate 90 degree function. If they remain the same, you can use either rotate 90 or flip left, right, and up and down. Okay? So now let's write our code. So here B is assigned rotate 90, and inside that we will send it A. So it will create a new matrix B that's assigned rotate 90A, meaning that it will take this matrix, rotate it by 90 degrees, and then it will assign it to B. So here you see our new matrix is what we wanted for B. So it's 2, 5, 6, 1, 4. Just to be sure. Okay, so it is what we wanted. So the way I like to think about it is, every time you do rotate 90A, what it will do is I will keep an eye out for the lower right element, or any corner element you can do, that's fine too. But I like to keep an eye out on the lower right element. And then every time you use rotate 90 function, it moves from lower right to top right, and then from top right to top left, and then from top left to bottom left, and then from bottom left, if you do it 4 times, it's just not doing anything. It will go back to this position. So every time you use rotate 90A, for this matrix A, this 4 will go from, initially it starts here, then once you do this 4 will move to the top right corner, as you can see right here. If you do it again, this 4 will move to the top left corner, up here, and then like this one right here. And then if you do it again, it will move down here. This 4 will move down here, and the matrix will shift accordingly. So let's do one more example with this. Here we have C is assigned a 5 by 4 matrix, and as you can see that this C, matrix C and matrix A are of the same size. So in this case we can use flip up down and flip left right functions. So I'll use both these functions and rotate 90 degrees function. In this case you can't directly do it. You have to use what's called nesting a function, which means you put a function inside a function. You can do it if you don't want to nest functions. You have to do 2 lines of code. If you want to nest functions, which is what I recommend doing, you can do it in 1 line of code. So what I would do here is rotate 90. Since you see that the 4 has moved from here to top left corner, so you have to use rotate 90 degree function twice. So I'll put rotate 90 inside rotate 90, and then I'll put the matrix A. So this inner rotate 90A, what it will do is it will create a new matrix that looks like this matrix B right here. And then it will take that matrix here. So imagine this is B. You're sending this instead of rotate 90A because that's what B is. Imagine sending it B. What it will do is it will rotate this from here to top left corner right here. So if you run this, you see that you get matrix C that contains elements 4728, 1975, and I'm assuming everything else is the same too. Now you can also use, I'll call it new C, you can also use flip up down and flip left right function, and flip left right functions to do it. It does not matter if you put flip up down here or flip left right because the end result will be the same. So I'll run this and flip flip left right. So you see that you get matrix C, new C is identical to matrix C, and that is how you would use these functions to move around elements in a matrix. So thank you for watching. See you next time.